We're looking at using soft robotic systems to manipulate the lunar and Mars surface materials to help further the development of human habitation on the surface. A soft robot is a mechanical system that is flexible and compliant, and not a standard hard or rigid system. Rigid systems, when they hit you, they hurt. On Earth, people do not work alongside robots because it's dangerous. Soft systems are far more compliant, so that if it hits someone, there's a lot less chance of getting injured and or killed from that contact. So soft systems in space make sense when we have robots working alongside people doing very dangerous tasks in very dangerous environments. So for instance, this is a structure that's enclosed on itself that's covered in silicone. And in this silicone, there's various cells or air bladders that we use to manipulate this system. We can get it to roll, we can get it to unfold and form various types of shapes. Well, currently, for our experiments in the lab, we're making them out of silicone, and we pour this into molds. We make those out of 3D molds we print on our 3D printers. Then we fill the silicone into those molds, we let it harden, and then wire the system up with our airlines and then do our tests. So first we look at leveling, we also look at shaping, we also look at joining, and then we look at locomotion. They're all very important because we intend to have many of these on the surface of the Moon and Mars to do the certain types of assembly and disassembly that we plan to do. But you can also use these soft robotics within the spacesuit to give them more power to lift, more power to run, more power to walk, and ease the workload on an astronaut for longer EVA in space.